Talk about law of sines. You had to know an angle and its opposite. You had to know an angle and its opposite in order to make it work. Now, law of cosines is for when you don't have that. So if you don't have an angle and the side opposite, you'll use law of cosines. Now, law of cosines looks really, really weird. Law of cosines is basically for when law of sines won't work. You're going to use law of cosines if you have side, angle, side. I don't want to leave the same marks. Use law of cosines if side, angle, side, or, and it's not back like that, all right? What it is, it's in the diagram if you have two sides and the angle between. If you have all three sides marked up. Because if you have two sides and the angle between, you don't then have the side opposite. See what I'm saying by that? That's why I write it as side, angle, side, or side, side, side. Okay. If you have, basically it's like if you have this at 37 degrees, this is 15, and this is 32. I have an angle, I have two sides, but I don't know the one opposite. So I would use the law of cosines to find that out. Now, what's nice about the law of cosines is that even though it's a little more complicated of a setup, you only have to use it once. Because the minute you use it once, you automatically will then have an angle and a side opposite, which means you can default back to the law of sines to finish it out. And as you saw yesterday, using the law of sines is pretty easy. Okay, it's pretty straightforward. So when you deal with what's called the law of cosines, there are basically three different scenarios that you can use. And the reason why I say that there's three different scenarios is because there's three different angles, three different sides. So what we do is we manipulate the equation so that way it's easier for students to figure out which one are you using via the parts that you have. Does that make sense? Because like when we had law of sines, there's still three parts to it. You're using two of the three each time to figure out the ratio. Well, in the law of cosines, it's not a ratio per se, it's just an equation. So let's take a look at it. Breathe. There are three versions of the law of cosines. Law of cosines Law of cosines is basically taking, we do this one at a time. I'm going to write it out a couple times here. What I want you to see here, excuse me, sorry, I got to erase the second name, but it was very, very nice of you. I ate some pie and it was delicious. It's math humor. Thanks.
Pi Day is actually a month from today.
So what I want you to look at is when you have these different scenarios, take a look at what's on the ends. You have little a on one side and big A on the other side. Little a squared, big A for the angle is on the other part. If I go through the rest of them, little b squared, big B. Little c squared, big C. So that's how they move themselves around. Now, if I'm looking at it if I'm dealing with angle A, that means I have these two parts. So that scenario makes it look like that. Okay. As we go through these, and I think it might be easier just to write them out and show you an example of how you piece it together. Because once you start to see how you're picking the values, it's, I wouldn't say it's as easy as the law of science, because you have to be careful with the subtraction piece. Okay. So there's two parts to these problems. So here's what happens. You have the a squared, so then you rotate it to the b squared. Well, then that means these two just change spots. And then you do it with the c value. I'll show you. Like I said, law of cosines has a lot of parts going on to it. Let's do one with angle first.
You know what I'm saying?
Okay. Let's take a look at an example.
Wow.
Okay. Take a look at an example, and as you see this, as you start to see what values you're given, it winds up being purely substitution as you get going. Okay.
So whatever the angle is what's the first one?
What's that?
Whatever the angle is the first.
Yeah, if you think about it, notice how you're given angle B, and then you have side C and side A. So if I have angle B, that means right away, which of the three versions of this would you use? I'd use this one because it deals with angle B. Which means, what are you going to try and solve for? Little b. So watch what happens. You have little a, little c, and little b. As I write out the formula, it tells me that little b squared is little a squared plus little c squared minus 2ac cosine of big B. Exactly. What do you have? I have little a. I have little c. I have angle B. Fill in the blanks. Don't I just have a whole bunch of junk that equals b squared? So what do you think we do? You quite literally put this in your calculator exactly the way that it's written. (45) squared plus 43 squared minus 2 times 45 times 43 cosine 88. Doesn't that look exactly like what I just wrote out? Yeah. What do you think I press now? Maybe enter. So what does that equal? B squared. I have to now that equals b squared.
Square root.
So what do I do? I square root it. Second square root of your answer. There's your side. Did you take the square root yet?
Yeah. So wise. Yeah, tell me about it.
You haven't taken the square root yet. That equals b squared. Take the square root of it. Because what's happening here is, remember, this
Oh, that's just from one side.
this whole string here, b squared equals 45 squared plus 43 squared minus 2 times 45 times 43 times cosine of 88. That equaled b squared. We got an answer. B squared equaled that crummy number. How do you undo squaring then? We took the square root of both sides and we got that. That's how you get that side length. So like I said, when you're working with law of cosines, it looks like it's going to be awful, especially when you're trying to find a side length, but it is quite literally pushing numbers in the calculator. Usually when you get to this part here, then you're just going to type in your calculator and just press this, and then you know how you do your second square root of your answer, and that's fine. So that gives me my side length of B at 61:15. Now notice what happens. Do you now have an angle and a side opposite?
Yes.
Yes. Isn't it a lot easier then to go ahead and switch to the law of sines?
No.
Yes.
I like this way better than the law of sines.
You only have to do law of cosines once. After you do law of cosines once, it's always easier to switch to the law of sines. Because now you have that. What's that? You can, but it's easier to switch to law of sines. Okay. Now let's do another one of side length before I show you what happens when you find the angle. That's where things can get a little weird.
Of course, there is negative.
Why not have one on here? Ah, let me get another one real quick. Sorry about that. I thought I had another one saved down there. Let's do the same basic ideas. Excuse me. Once again, we have triangle ABC. In this case, you're given angle A. There's little b, little c, little a. What version of the law of cosines is this forcing you to use? A. And why is it forcing you to use A? Because you have the angle A. So write it down. Little a squared is b squared plus c squared minus 2bc cosine of A. Once again, fill in the blanks. As you fill in the blanks, you're going to get little a squared is 17 squared, 30 squared, minus 2 times 17 times 30 times the cosine of 28. All of that equals b squared. Type, yeah, exactly. You type the whole thing through. So we have 17 squared, 30 squared, minus 2 times 17, 30, cosine 28. Excuse me. That number equals b squared. So what do you press? Yes, sir. Great. So you take, hopefully by now you guys have gotten accustomed to using the answer button. Okay? Second square root of your answer, and there's your side, 16.98. And that's little a. Now, again, as I've been saying, once you now know a side, excuse me, a side and it's the angle opposite, then you go back to sines because this is always quicker. It's quicker to cross multiply than it is to type all that in. Okay. All right. Yeah.
I did it. I did the same thing, and I got
Bless you. Yeah, oh, I see. Little A is and that's, you see, that's what's awesome about those about calculators. You can go up and see what you typed in, and I go, oh, you just corrected yourself. All right. All right. So not always. There's also this other time in law of cosines that you probably won't like as much, and that's when you have all three side lengths.
Don't tell us that. Just do it.
All right. Sometimes you're going to be given just three side lengths, and you have to know about your angles. Well, how do you find an angle? What button do you think you're going to have to press? You'll have to use an inverse at some point. But what I want you to realize is that it's going to be a multi-step equation. There's actually three parts to it. Okay, it's a three-step equation. Now, one of the generic rules that you guys are going to find out later on in Algebra 2 about law of cosines, and eventually also law of sines, is that, I think I mentioned yesterday, within the law of sines, there are certain parameters that sometimes you could not have a triangle that's created. You can have two triangles that could be created, and some things like that. Well, that's kind of a weird offshoot that happens from time to time. Now, in geometry, don't worry about any of that. But one thing I always want you guys to remember when you're using law of cosines, if you have to find an angle, basically if you have all three sides, always find the largest angle first. Always. Okay? That's really like the only rule that I can tell you about for law of cosines. Find what would be the largest angle first. And we all know how to do that, right? Figure out which one's going to be the largest angle. Which one's the largest angle in here? B. Good. Now, the reason that we do that is because it basically eliminates what's called an ambiguous case of the law of sines for later on. I know,
Sorry, I was gagging over here.
it's a lot of math, let's just say that. And by finding the largest angle first, you eliminate the possibility of having to worry about it, okay? So, in this case here, what angle do you need to find first? B. So, I'm going to write out the law of cosines in terms of B. So, we'll have B squared is A squared, C squared minus 2AC, and then the cosine of B. Everybody okay with that? I have to find B because it's the biggest angle, so that's why I'm writing this out first. Let me move this over a little bit so I have some room. I'm assuming you guys all have that written down by now. So now I fill in the blanks. What is little b? So it's 27 squared. Little a? 23 squared. Little c is 16 squared minus 2 times 23 times 16 times the cosine of an angle B. Everybody okay with me so far?
Yep.
Okay. Now, what I need you to do is, what's 27 squared? Ends in a 9. 707. 700 what? 23 squared ends in a 9. 16 squared is 256, right? Now, what's 2 times 23 times 16? 736? Thank you. Okay. That looks pretty crazy right now. But what I want you to think of, it's nothing more than this. It's the same thing with bigger numbers. What do you do here first on this side? I add them together. So what's 6 plus 3? Okay, so here, what am I going to add together? What is it? Add these two together. I'm doing the same thing as I would do here. What is it? 785? Okay? What would you do here? Subtract what? Subtract the 9? Okay. So then 15 minus 9 is 6. And now this was a negative 4x, right? So it brings the negative 4 down, correct? Just like it would normally. So what am I going to subtract on that side? 785. So now 729 minus 785 gives you a negative, which is fine. Negative 56 equals negative 736 times the cosine of b. Again, we're doing the same math, which is bigger numbers. How do you undo multiply by negative 4? I would divide both sides by negative 4, and I would get my answer here. So what do I have to divide by now? I can't divide by the cosine of b. I'm just going to divide by the negative 736. And this is a good sign, because what's a negative divided by a negative? Okay. Now, can you have a cosine of an angle that's negative? Or can the cosine of an angle become negative? Yes, because it's more than 90 degrees. It's okay, but we'll worry about that later. What do you get when you divide these out? You get chromidecimal, right? Chromidecimal equals the cosine of b. Octidecimal equals the cosine of b now, doesn't it? So in your calculator, what you have is negative 56 divided by negative 736. You have this ugly decimal, right? 0.07608, whatever. How do you get the angle out of that? Ah, it's not sine, it's
second cosine.
second cosine. Oh, sorry. There's my angle. So what happens here is that this, when you're finding the angle, it just takes a couple seconds longer.
So there's a harder way of finding this?
What's that?
There's a harder way of finding this?
I don't know if it's a harder way of finding it. I just want you to remember that you're doing basically the exact same thing here, but at the very end you have to take the inverse cosine. That's it. If you break it down into that, it looks like it's awful, but it just takes a little practice to get used to it. Okay? And now, once again, notice what happens. 85, 64. At that point in time now, what do you have? You have an angle and side opposite, which means you're going to go to. Let's try another one like this. When you have to find the angle, yes, they take longer to find. Okay, when you have to find the angle, yes. Let's try another one.
No. No.
Guys, come on. Okay. Triangle ABC. Side lengths of 4, 6, and 5, respectively, for sides A, B, and C. Which angle is it forcing you to find first. B. It's forcing you to find angle B first because B has to be the largest angle. So write out the formula in terms of B. Okay? Fill in the blanks of what you know. I know that little b is 6. Little a is 4. Little c is 5. What's 6 squared? What's 16 plus 25? Two times 4. Who do we appreciate? 2 times 4 times 5.
How's he looking at you?
Notice you're back to something like this then. What do you move now? 41. Move the 41 over. What's that? Not necessarily. Well, this one goes negative here. You could get a positive side of here, then we divide out, it becomes negative, because then that just means that your angle B is going to be obtuse. And that's an algebra 2 reason, because it's past 90 degrees and it's second quadrant. It's a fun time. When you get to this part, it is pure calculator after this. You have to move that negative 40 by division. And then you get this crummy decimal equals the cosine of an angle. You get this decimal, 1/8, equals the cosine of b. So what buttons do you press? Inverse cosine of your answer. There's your angle. 82, 82. 82, 82. Okay. Let's see what I have here. Not ready to go.
I was gonna give you the Hershey's time, but Maria. I was gonna give you the Hershey's time, but yeah, I know you are.
So let's do this. Guys.
You're welcome. Oh boy.
We're not solving full triangles. We're going to find parts. I just want you to practice it a little bit tonight, okay? We'll build into this more tomorrow about using this to get into all of the solving out everything else. So on the study guide side, number 1, find little c. 2, find little b, because you're given those two larger angles. And then on 4, it's a side-side-side setup, which means you have to find the largest angle. Well, I'm telling you right now, it's going to be angle C. When you flip over to the other side, it's the same deal. On number 5, you have 3 side lengths. You're going to find that largest angle as well. What's that, sir?
We don't have to do number 3.
No. I figured we'll do these 4 for right now, and then we'll build out of this more tomorrow. Okay?
Mr. Murphy,
Yes, sir.
can I get a flex pen?
Help yourself, man.
Somebody said yes, and I was like, okay. Everybody.